Anecdotal stories being what they are. The node copter, as it's called sometimes, is nothing more than a Parrot AR drone. And Parrot AR drones have a wonderfully odd feature about them that you can control them through the Wi-Fi over a UDP communication stack, which Andrew will go into more. It sort of started randomly when 4 Germans got together and decided, let's do this, pun intended. Things took flight on their own. And nodecopter events have happened around the world. I don't know if you've been able to attend them. They've spawned into different languages. Ruby copter, Clojure copters, basically take a language and add the word copter at the end, because that's, I guess, what we do. And so without further ado, flying in the skies, Andrew Nesbitt.
Okay, I'm T-Bass. I just started working at GitHub over from the UK. And I'm going to focus the talk on the AR drone. We also have some crazy fly robots, which are much smaller, and you can also programmatically control them, but we have a lot more AR drones, so a lot more of you will be able to play around with them. And what makes these really interesting is they're absolutely full of sensors and equipment that you can use. You can buy these off Amazon, and we don't make any hardware modifications to get them to work programmatically. So you've got things like your gyroscope and your accelerometer, so you can sense its position and direction that it's moving in. It runs BusyBox Linux on a 1 gigahertz ARM CPU internally. So you can actually telnet to it as it's flying and run arbitrary shell commands, like in the cloud, but literally in the cloud. It has a HD camera on the front and a camera that's looking at the ground on the bottom as well. And all of this is available to you over a UDP API. So as they generally get called nodecopters, but really that's only because it started out where people were programming them with Node, but the communication is all over UDP. So anything that can talk to a socket can talk to an AR drone. Kind of inspire you that people have built before the AR drones. This is probably the only valid use of a QR code that's ever been performed. Basically encoding a command into a QR code, showing it to the camera of the drone execute that. So you don't actually need to write code to it, you can just show it pictures for things it wants to do.
Gangnam Style.
Then you have the ability to control a drone using the kind of interpretive dance method. So we have a dance snap and the ability to dance along with the drone. Julian, is Julian in the room? He's around. If you want to see him do the dance, then he will dance for $1, I think. So you're able to then map. This is essentially like a PlayStation controller that you plug in your laptop as USB device, and it acts just the same. It's just you step on it rather than press regular buttons. And we mapped a few different extra commands to extra arrows.
Gangnam Style.
Pretty good timing. Obviously, it ends up upside down. The one that I hooked up is freakishly long arms to control the drone. Basically, if hands are in front of my hips, then it would go forwards. So behind, it would go back, or twisting around. And then if my hands are up in the air, the drone goes up or down. And if I jump, the theory is it should flip as well, which doesn't always work. But you can start to see the way that people can mash up these. Essentially, the API for the feature is fairly high level, so you don't have to worry about the implementation details. You don't have to worry about working out how to get it to balance or to stay flat. You really can say, like, go forwards, go left, go right, and it will act like a really nice high-level API. So then you can start to mash it up with other different bits of hardware or even web services as well. Then you can get stuff like Robot Laser Pong, where we're using Johnny 5, and you can't really see it, but down the front here, we've got a couple of servos and a laser, and then we've got 2 drones, which are mirroring the paddles of the game of Pong, and then the laser, which you occasionally see moving around on the screen, is supposed to be the ball. Not the best demo in the world, but quite fun to try and put together, orchestrating a number of different bits of hardware. Of course, the drone just tries to smash the TV to pieces. These things have a mind of their own. Of all the robots that we have here, I'm pretty sure these are the things that are plotting to kill us the most. This is my attempt at drone art, where I fixed a pen, basically just a whiteboard marker to the front of a drone. I think this is the first bit of drone art ever created. It's like an impressionist piece, but many years to come, it will be a sign that of the drone's future intentions, I think. Some actual things that we can do as well. So I'm going to do are using Node.js, but I'll show a few slides a little bit later for different libraries in different programming languages that you can use as well. So the first thing we've got is, where are we? A basic, like the simplest thing to get something to work. So this is basically all the code you need to get the drone to lift off the ground, spin around in one direction, spin around in another direction, and then land. Really easy. Like, you can essentially then start to copy and paste pieces together to build up more complicated, scripted sequences. So we can just run that. You connect to the drone as a Wi-Fi hotspot. So I've got number 18 here. So it's like a flying router as well as being, so you can actually telnet to it. You can get it to connect to another Wi-Fi network because you can just drive the Wi-Fi card in it as any other Linux machine. So we're connected to that now. We can just run, this is using Node. This JavaScript file, which is using the AR drone library, which is on NPM. Just hit enter. And I'm no longer in control of the drone. So that's quite nice. So definitely going to need the screen a bit bigger for this one. So the next thing I thought, well, I work at GitHub. We use Hubot a lot, which is our chat room robot. He does lots of automated tasks for us, like deploying the website. It'd be great if I could ask Hubot to fly my drone around for me so that I didn't have to do it. So there's a Hubot script which adds in extra commands. So we can ask Hubot, Hubot, what's the battery level? And he says, I don't know what you're talking about. Oh, okay. Let's see if it'll take off. Okay, so that's quite nice. The only problem with this, thank you, Hubot, is that you have to type fairly quickly. It's good, I got this. I just need it up in the air a little bit more. So I've intentionally made it move very slowly. You can make it move a lot faster than this. But if you can type that fast, that's impressive. And then, of course, we can flip. Is an English Hubot, this one. So let's bring him back down. Oh, you can't see his witty remarks. That's quite a fun way of doing it, but again, trying to type and control your drone, not the best way. You want to have better kinds of control. So first-person shooter-style keyboard commands are quite a nice way of doing it. I usually fly it around with an Xbox controller, but I didn't have one with me to try this out. So this is using and Chris runs off to find an Xbox controller, maybe. Awesome. So this next demo is using a project called AR Drone Webflight. Oh, Chrome. There we go. what this is doing is it's running, as well as connecting my node process to my drone, it's running a web server. So in my web browser, I'm able to open up a web page, which then connects back to my node process using a WebSocket. Then every piece of data that comes from the drone is proxied through the node process up to the web browser, and then used to visualize different pieces of data in the browser. So you can see at the top right, we have the battery level. It's about 46%. We've got a horizon line and a number of other kind of heads-up display bits. And right down the bottom, you can't really see, is a compass as well. So without actually flying this, we're still getting data through. And we're getting the frames of the video, which are inserted into the back of the page as well. And this data, you get a huge amount of data from this. It's only using a small portion of it. You'll get every piece of sensor data it will use on board. You can also use from remotely on your laptop. Take off. He says. There we go. I haven't got any video. So now I feel a little bit more confident that I can control it as I'm flying it around. So we can start swooping over the audience a little bit more. Come back. I should say that you've probably all signed some kind of disclaimer that you don't realize that says, it's not my fault if the drone turns sentient and we get Skynet. So this is quite cool. The project also comes with a number of different plugins for adding in different elements into the page. So you're able to control it with their gamepad API in the browser. There's I don't have any internet right now, but someone's made a plugin which will show airplanes that are nearby in augmented reality. So you actually see the name of the flight on the screen. As it spins around, you'll see where the planes are within 10 miles of here, which is quite cool. It's all right, we can make it dance instead. So the next obvious, if I can fly it around controlling it myself, it'd be really fun to make it fly autonomously instead. And the best kind of use of autonomy would be to make it dance a dubstep, I assume. So we've got a very similar setup again. I've got another node process which is running a web server as well as connecting to the drone. We've got a CSS3 subwoofer in the browser. It's going to use the HTML5 audio API to play an MP3 and then analyze the MP3. For every time there's a frequency drop over a certain threshold, it's going to tell the drone to go up or down and dance along in time with the music. So, it dances along with the music. And then it's throws the camera. Just before it takes everything out, that rather than thinking of it as the bare components, we just treat it as if it's just somewhere we can read and write data from. It just happens that the output of writing data to it means that it flies around the room. So here's some different kind of things that people have done before, or I think would be really cool to do. So everyone has a leap motion. Trying to control one of these with your hands, tilting them around would be really cool. You could actually detect faces using the camera, and maybe make it record everyone's face, take pictures of them, or just put troll faces or moustaches over the top of them as it flies past. You could do things like try and map out the room by looking for the edges of the room in the camera as you go past. If you put some Velcro on it, you could potentially pick stuff up off the ground. It won't be able to lift very much, about 100 grams in weight maybe, but you could get some interesting stuff. You put some Velcro and some lasers on it, then you've got the ultimate cat machine that you can just swoop in and pick cats up, kind of set the laser up to get them ready for it, and then whoosh. And because you can control the Wi-Fi in the drone, you can actually get the drone to connect to a different Wi-Fi, and then you can have multiple drones at your command at once, which makes for all kinds of interesting swarm activities that you could do. You could potentially even, I would love to see someone do this week, is to actually, rather than Amazon's PR stunt where they're like, oh yeah, we will do this in 2 years, we can do this in 2 days. Then basically we would remove the need for Amazon to actually implement this, because that would be pretty much the same thing. So I'm just going to run through some of the different libraries that there are. All these are really easily Googleable. If you just search for Nodecopter or AR drone on GitHub, you'll find them all really easily. So this is the JavaScript one. This is pretty much the same as the demo code that I ran a minute ago, which is called AR-drone. We've got R2, which uses a library called Argos, which is a Ruby gem. It's not quite as fully featured. I don't think it lets you flip, which is a minus for me. But it does let you write stuff with Ruby. Potentially, you could add a drone module to your Ruby on Rails app, which would be quite fun. And the code is actually really nice. Being a Rubyist, I find this nicer to read and to look at. Then there's Cylon.js. This actually uses the AR drone library from Node underneath, but gives you a higher level interface. So it's really nice if you're going to be integrating things like Leap Motion or Sphero with your AR drone project. So you can basically add in a drone to any Cylon project really easily. And the code is fairly similar to R2. It's made by the same guys who I think they're all sat outside by their massive pile of T-shirts. And they're all really experienced as well, so if you have any more questions, then they can help out as well. There's a Python library. I've not used this one personally, but it's got a fair number of stars, so probably people are using it. And the code is really simple and has no nesting, which is weird for Python, but not going to complain. There's a Go one. This is really experimental. I don't know what would happen if we actually tried this out. And the code has lots and lots of timeouts. There's even, if you really like pain, there's a closure one. I don't know what this code does. Who knows? It's probably going to make the drone fly, maybe? It doesn't actually make it. Oh, it does land eventually. And do something really crazy, and maybe you don't want to fly the drone out without knowing exactly what it's going to do. You can actually use this. It's really dark here, but check out the URL in a browser. Search for voxel drone. This is a virtual drone that exists in the browser inside of a Minecraft-like world. If you open up the JavaScript console, it's the same API as Nodecopter is in the terminal. And the virtual drone will do exactly the same thing, which is really awesome for trying stuff out when either your batteries are running low or you don't want to hit someone because you really don't know what it's going to do. Or if you were going to fly outside and you're like, I'll just check that this is going to do what I think it's going to do before the drone drifts off into the sea. I figure people are going to have kind of similar questions as I get a lot of same questions. So if anyone has any questions, then come find me afterwards or any of the R2 or Cylon guys, and they'll be able to help out as well. So thanks very much.